little bit harder. And so for general, this is number 2 from the questions that we started last month, right? So this time the situation's a little bit different. My son and I are still starting out on the top of the hill. We probably wouldn't be standing, but maybe we would. We're still starting out on the top of the same hill, right? We're going to the bottom, but not all of our gravitational potential energy is changing into kinetic. Right? Some of that mechanical energy is being removed because there is friction with the snow that's going to create some thermal energy, and there's also collisions with air molecules. So these are not equal. We're going to have more mechanical energy at the top of the hill than we'll have at the bottom. Right? But we happen to know how much energy we're losing. 590 joules of this initial energy, initial mechanical energy, does not change into mechanical energy over the course of sled. So the way that I'm going to handle that, and you might choose to think it makes sense to do it a different way, I'm going to subtract that 590 joules out of here. Right? So however much energy I have here, if I take away 590 joules, then that will be how much mechanical energy I'll have at the end. It would be just as good to add that missing energy to this side. I'm just going to go ahead and subtract it from this side. So I'm going to rewrite this. All right, well, so this is not equal. Let me leave that as not equal. So my initial gravitational potential plus my initial kinetic minus the work that's done by the friction and the air resistance then will equal my final potential and final kinetic. All right, so I absolutely have initial gravitational potential energy. That's m times g times the initial height. We do not have any kinetic energy. We don't do a running start, right? We're starting from rest. And then I'm subtracting out the 590 joules. I'm not going to worry about subtracting a negative. I don't want to do that, right? There are 590 joules of this that aren't going to show up over here. So I need to make this amount smaller by 590 joules. I'm not going to subtract a negative. I'm just going to subtract that energy that friction and air resistance takes away. When we get to the bottom, there will not be any gravitational potential energy. We will have kinetic. All right, now, do I want to cancel out the masses? I don't want to cancel out the masses. I did give you our mass, right? But we don't want to cancel out the masses because there's no term for mass here, right? Unless I want to go ahead and divide this by the 81 kilograms, right? I want to leave the masses into my other energy terms. Algebra is great because it allows us to do anything we want so long as we do it to everybody. So if we're going to divide out the mass here and here, we have to divide it out here also. I'm not going to divide it out at all. So I've got 81 times my 9.81 times the 22-meter high hill. All right, I'm subtracting the non-mechanical, or subtracting the mechanical energy we're removing. And then I don't know our speed at the bottom. That's what I want to find. All right, so this should be the same as we probably didn't calculate this already. Because probably in the earlier parts you did cancel out the mass. All right, so if I subtract the 590, I get something like 16,891, and that is precise to the thousandths place only. And then I will have to divide both sides by the 40.5. So I have 417.1 if I want to go one further. And that should have 2 significant digits. Equals my final speed squared. And then I go ahead and do my square root for both sides. So I get like 20.42 to 2 significant digits. So this is one of those times that we have to put it in scientific notation. 2.0 times 10, or 2.0 times 10 to the first, whichever you prefer, meters per second. So only a little bit slower than when we said mechanical energy was conserved, because 590 isn't so big, right, in comparison to 18,000. So we're only losing a tiny bit of speed. All right, yeah, Ben. Why do I have to put it in scientific notation? Because I get 20.42, but I need to round that to be precise to the ones place. And this does, the ones place does not round up, it stays as 20. But I can't make, a final zero is only significant if it's after the decimal point, and that's not after the decimal point. right? So the only way to make that significant is to shove it after the decimal point, which means I need an extra. Other issues? All right, great, so let me stop recording. Now, can we take 2 more minutes and compare your answers to the other homework questions? Right, we've only gone over 74. Just compare your answers to the 4 qualitative questions before we go over those.